Today we will study about aromatic, anti-aromatic and non-aromatic compounds. So let's study about first aromatic compound. It is the most stable compound in entire chemistry. So wherever you have got a aromatic compound, it is the most stable compound. Okay, so how can you know that is a compound is a aromatic compound? We have Huckel's rule for that. Okay, first, a Huckel's rule are comprised of four points. For example, Huckel rule says that for a compound to be aromatic, it must be cyclic. So cyclic compounds are aromatic compound, but non-cyclic compounds are called non-aromatic compounds. Well, first you will check whether the compound is cyclic or not. Second, you have to check conjugation in the ring. So whether the compound has conjugation, complete conjugation in the ring, you should check the complete conjugation. If there is complete conjugation in the ring or not, you should check it out. I will check it out like pi sigma pi bonds or pi sigma lone pair, pi sigma positive or vacant p orbital. Okay, or delocalized electron conjugation means delocalization of electrons within the ring. So you will check this out. If the compound has no conjugation in the ring, then the compound is never aromatic compound. So third point is also necessary, planar. That is, the compound should be planar. That is, it should be two-dimensional. Okay, that is, it can be formed lie on a plane given. You can't know a compound is planar or not. It is always given or by the book, or you have read somewhere that it is planar. Okay, so if in the question there is nothing given about the planarity of the molecule, you will consider it to be planar to check these rules. So it is always given in the book or the question. So read CsP2. I mean the compounds. I mean all the carbon atoms in the ring should be sp2 hybridized to be planar. I mean, if even one compound in the ring is sp3 hybridized, then it is not planar, thus it cannot be aromatic. So you should check this thing, that is the each carbon in the ring should be sp2 hybridized. This is very necessary to know. The 4 point is very much important. After checking these three, you should come for the fourth one. Okay, so what does it say? 4n plus 2 pi electrons, where n equals to 0, 1, 2, 3, 4. That is, in ring the pi electrons should be this much only, then only it can be aromatic compound. Okay, you should count pi electron and lone pair electron both. Okay, you should count pi electron, lone pair electrons both, which are in conjugation within the ring. So if you put n equals to 0, you will have 2 pi electron here. Okay, and if you put 1 there, you will have 6 pi electron. If you will put 2 here, you will get how much? 8 plus 2, 10 pi electron. If you put 3, 12 plus 2, 14 pi electron. So 4n plus 2 pi electron. You should check the number of pi electrons plus lone pair electrons in the ring. If it satisfies this formula, then the compound is aromatic. So aromatic is most stable compound in chemistry. Now we'll talk about anti-aromatic compound. What? Anti-aromatic compound. It is the least stable compound in chemistry. If you got anti-aromatic compound, you should place it to be the least stable compound in chemistry. So the how will you know that a given compound is anti-aromatic? You'll have to apply these four rules again. The first three rules are same as Huckel's rule for the aromatic compound. So first, the compound should be cyclic for a compound to be anti-aromatic, and conjugated, that is complete conjugation there should be in the ring. So anti-aromatic compound, and the ring should be planar for it to be anti-aromatic. So here we have, and this formula must be learned. 4n pi electron, 4n pi electron, 4n pi electron, where n equals to 1, 2, 3, 4 dot dot. It cannot be 0, because what will you get if you put 0 here? 0 doesn't matter now. So 1, 2, 3, 4. So like if you put here 1, 4 pi electron, 8 pi electron. If you put here 2, 8 pi electron. 4n pi. If you put 3, then 12 pi electron. If you put 4, then 16 pi electron, and so on. How about non-aromatic compound? You should learn this way: compounds which are neither aromatic, nor anti-aromatic, are known as non-aromatic. Like this, there is no ring, so first is not satisfied here, so this is non-aromatic. Here you can hear you get sp3 hybridized carbon atom here, and so there is no conjugation inside this ring. Cyclic, it is cyclic, but there is no conjugation in it, so this is non-aromatic. You can here this is also an example of non-aromatic, because this is cyclic but there is no conjugation inside it. Pi, sigma, so there is no conjugation in it. CH4, it is not cyclic. So non-cyclic are non-aromatic compounds. The non-aromatic compounds has a stability in between these two, that is anti-aromatic is the least stable, this is the most stable compound, aromatic compound, and non-aromatic comes in between of them. So let's learn about stability. Aromatic is most stable, then we have non-aromatic, then we have anti-aromatic compounds. So this is the stability order of these compounds. Note the conditions are for ring only. Inside the ring, the conditions you should apply to check whether it is aromatic, non-aromatic, or anti-aromatic. So this we have here examples. So for this, okay, so you will check whether it is cyclic. So it is cyclic, and then there is conjugation inside it, pi sigma pi sigma pi sigma. So there is complete conjugation inside it, and I will tell you that this is planar molecule, and you have to count the number of electrons, pi electrons. How much pi electrons are there? 1 2 3 4 5 6, 6 pi electrons there are. So it is aromatic because it satisfies this formula. If you put here 1 n equals to 1, how much pi electron you will get? 6 pi electrons. So this compound is aromatic because it satisfies all the 4 rules, including the Huckel's rule. How about this? This is cyclic, you can know. Then this is conjugation. It has complete conjugation inside it. Yeah, pi sigma lone pair, pi sigma lone pair. So complete conjugation. How many electrons are there? Pi electrons, 1 2 3 4. You should count these two, 1 2 to 6 pi electrons, because these are also in conjugation inside the ring when they are delocalized inside the ring. So how many pi electrons? 6 pi electrons. You should count the lone pair electrons also. So all the 4 rules are satisfied here: cyclic, conjugate, planar, and 4n plus 2 pi electron. So this is aromatic electron, aromatic compound. Okay, how about this? This is non-conjugated. It is cyclic, but it is not conjugated, because you can see here sp3 hybridized carbon atom. Here also sp3 hybridized carbon atom. So in ring where sp3 hybridized carbon atom present, it is not conjugated. Okay, so non-aromatic, it is also non-aromatic. Then let's talk about it is cyclic, conjugated, and it is planar, I will tell you. And how many pi electrons are there? 1 2 3 4. So 4 pi electrons, it means it is anti-aromatic compound, because 4 n pi, if you put n equals to 1, 4 pi electrons, the 4 pi electrons refers to anti-aromatic compound. Let's talk about this. This is cyclic, conjugated, and planar also, I will tell that. And there are 4 pi electrons which are delocalized, so it is also anti-aromatic. How about this? This is cyclic, conjugated, and 2 pi electrons, so it is aromatic. It is conjugated, non it is cyclic but not conjugated. Okay, so it is non-aromatic, anti-aromatic, so it is non-aromatic. This is cyclic, conjugated, and planar, and there are 6 pi electrons, so this is aromatic. How about this? This is non-conjugated, so non-aromatic. This is cyclic, non-conjugated, so non-aromatic. This is cyclic, conjugated, planar, and 6 pi electrons, so aromatic. How about this? Uh, Cyclic, conjugated, planar, and 2 pi electrons, so aromatic. This is cyclic, conjugated, and planar. It is planar, I will tell you. But how many pi electrons? 4 pi electrons, so n type aromatic. It is non-conjugated, so non-aromatic. It is cyclic, conjugated, and planar 6 pi aromatic. It is also known as pyrrole. Conjugated, cyclic, and it is planar. This is thiophene, 6 pi electrons, because this don't count this electron because it is not taking part in the conjugation or delocalization of electrons, so aromatic. And how about the pyridine? This is cyclic, conjugated, but don't count these electrons. it is localized. So and 6 pi electrons aromatic. So if I'll ask you which is more basic in nature, pyridine or pyrrole, you should answer pyridine, because in pyridine localized lone pair are present, but in pyrrole there is no localized electron pair, so it cannot donate electrons. So electron donor is pyridine, which is better electron donor, so it is a better Lewis base. This is a cyclic, conjugated, and planar 6 pi electron. The aromatic, you should not count these electrons to get 8 pi electrons, because it is not taking part in the conjugation. How about this one? This electron will be attracted to the electronegative oxygen atom. So here you will get negative and positive. So this ring is conjugated, cyclic, and planar. I have to tell that to you. And how many electrons they are present? 2 pi electrons. So aromatic. So this is aromatic compound. If you do this in the same way, 1 electron here, then 1 electron here, positive, then cyclic, conjugated, and 1 2 3 4 5 6 5 electrons, so aromatic. So this is cyclic, conjugated, 6 pi electrons, aromatic, 1 2 3 4 5 6 pi electrons. This is conjugated. Yeah, this is also conjugated, 8 pi electrons, so anti-aromatic. I will do about multiple rings like bicyclo. So naphthalene, this is conjugated, 1 2 3 4 5 6 7 8 9 10, and this is conjugated, cyclic, and planar also. So 10 electrons, 10 pi electrons. So this is aromatic, which is naphthalene. This is anthracene, which is cyclic, uh, conjugated, and planar. And how many pi electrons are present? 1 2 3 4 5 6 7 8 7 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So 14 pi electrons. So this is aromatic. This is biphenyl. This is not bicyclo, because biphenyl, so you have to check only this ring or this ring to be aromatic, because they are not made from two same carbon atom. Here two same carbon atom, they are different, so aromatic. So this is aromatic, this is aromatic, so whole compound will be aromatic. Okay.